derivative and integral of hyperbolic function. The hyperbolic function sine and cosine are defined as sine of x equal e to the x minus e to the negative x divided by 2 and cos of x equal to e to the x plus e to the negative x divided by 2. We have other hyperbolic functions such as tangent, cot, sec, and cosecant. The graphs are shown here. Now, let's talk about the domain and range of all of this hyperbolic function. The domain of the hyperbolic sine cosine is from negative infinity to positive infinity. The range is also from negative infinity to infinity. Cos have the domain of negative infinity to infinity, and the range is from 1 to infinity. The hyperbolic tangent have the domain of negative infinity to positive infinity. The range is going from negative 1 to 1. Negative 1 to 1. Hyperbolic cotangent have the domain from negative infinity to 0 union with 0 to positive infinity. The range is from negative infinity to 0 union negative infinity to negative 1 union with 1 to infinity. The hyperbolic secant have the domain of negative infinity to infinity. The range is from 0 to 1. And cosecant, the hyperbolic cosecant, have the domain of negative infinity to infinity, the range of negative infinity to 0 union with 0 to positive infinity. We have formula for derivative of hyperbolic function. Derivative of hyperbolic sine equal to hyperbolic cosine. Derivative of hyperbolic tangent equal to the square of the hyperbolic secant, and so on and so forth. We will use this formula in our calculation for integral and derivative. We have formula for integral hyperbolic function as well. So let's just perform this calculation. Here we want to find the derivative of hyperbolic tangent of x squared plus 3x. So we first have to apply the derivative of hyperbolic tangent, and we then have to do the chain rule, right? So derivative of hyperbolic tangent equal to the secant square. So secant, hyperbolic secant square of x squared plus 3x. Then we apply chain rule. We take the derivative of x squared to get 2x, and derivative of 3x get 3. Now, in the next one, we can rewrite this as derivative of sinh to the negative 2x. So we first have to take derivative with respect to we need to use the chain rule. So here we get negative 2 sinh of x to the negative 3. Now we have to take derivative of sinh, that get us cos of x. So let's double check. Is derivative of sinh equal cos x? Yep, so that is it. Now here in this case, we want to take the integral. So we will use the u substitution here. So I'll let u equal cos of x. Then du equals sin x dx. So I can see here it didn't help me much, right? So what I would have to do is let's rewrite this. Let's change this a bit. Let u equal sin of x. Then du equal cos of x dx. Then I can rewrite my integral as the integral of uq du is equal to 1/4 u to the 4 plus a constant, and use the substitution. So we have sin to the 4th of x plus the constant c. Okay. The next case, we have the integral of hyperbolic tangent. So let's see, what do we have for our formula? The integral of hyperbolic tangent well, we don't know. We don't have the formulas. But we can rewrite the hyperbolic tangent. So the hyperbolic tangent equal to sin over cos. Again, I'll use u substitution. Let u equal to cos x. Du equal to sin x. So then my integral becomes du over u, and this is ln of u plus a constant, and that is ln of cos of x plus a constant. Next, let's talk about the calculus of the inverse hyperbolic function. So here we have the graph of the inverse function, and let's see what are their domain and range. So the domain of the hyperbolic sine inverse, the domain here from negative infinity to positive infinity. The range is from negative infinity to positive infinity. For cos, we do have to restrict the domain of the function in order to make it 1-to-1, in order to have the inverse. So the domain here is from 1 to infinity. The range is from 0 to infinity. For hyperbolic tangent, the domain is from negative 1 to 1. The range is from negative infinity to infinity, and the rest is as follows. So here we have the formula for derivative of hyperbolic function. It's similar with the inverse of hyperbolic, similar with inverse of sine cosine, and our trigonometric ratio actually. Derivative of the hyperbolic sine inverse is equal to 1 over square root of x squared. 1 over negative x squared for cos. Note that x is greater than 1. And there's a typo here. So we have the derivative of the cotangent inverse. So this should say d dx of cotangent inverse, hyperbolic cotangent inverse of x. Okay, and we have the formula for integral of the inverse hyperbolic function as well. Note that the integral of 1 over 1 minus x squared, it can result in inverse hyperbolic tangent or inverse hyperbolic cotangent depend on the value of x. Okay, so here, so it becomes hyperbolic cotangent inverse if x is greater than 1. Okay, so let's take a look at this example. Let's do the following. Okay, we want to find the integral from 0 to 1 of 2 over square root of 3 plus 4x squared dx. Now compared to our formula, we have 1 plus x squared. We don't have 3 plus 4x squared. So here we have to do a little u substitution. Before we do that, we also need to do a little factoring. We need to clean this up a little bit. So this equal to the integral from 0 to 1 of 2 over, I will factor out 3, then I have 1 plus 4/3 x squared dx. So this is the integral from 0 to 1 of 2 over root 3 all over square root of 1 plus 4/3 x squared dx. So assign 4 over 3 x squared is the same as saying 2 over root 3 times x squared. Okay. So what I'll do is I'll go ahead and let u equal 2 over root 3x. Then du equal 2 over root 3 dx. I will change my upper and lower limit. So then when x equal to 0, u equal to 0. When x equal 1, u equal 2 over root 3. Now I can rewrite my integral as 0 to 2 over 2 root 3 of 1 over square root of 1 plus u squared du. So then this equal to send inverse of u, evaluate from 0 to 2 over root 3, and that equal to 0.9865. Now, in the next problem, we're looking at the integral of 1 over 2 times square root of 1 minus 9x squared dx. I go ahead and let u equal 3x. So then du equal to 3 dx. So 1/3 du equal dx. I can rewrite this integral as one half times 1/3 du divided by actually here noted that we have a 2x in the denominator but u equal to 3x. Okay. This meant that we can solve for 2x in terms of u. So this meant 2x is equal to, we multiply by 2/3 to both sides, 2/3 u I substitute this whole thing into my integral. Then I will get 1/3 du divided by 2/3 u times square root of 1 minus u squared du. This simplified to be 1/2 du divided by u square root of 1 minus u squared. And so we have 1/2 hyperbolic secant inverse of u. And u was 3x plus a constant. The next thing, we want to take the derivative of hyperbolic cosine inverse of 3x. The derivative of it is equal to one over 1 minus 3x squared, and then we have to take the derivative of 3x, that is 3. This simplified to be 3 over 1 minus 9x squared. Here we assume that x is greater than 1. Here we have to take the exponent rule and then we apply a chain rule. So then you have 2 hyperbolic tangent inverse of x. Now you then multiply with the derivative of the hyperbolic tangent inverse, that is 1 over 1 minus x squared. Okay. So simplify this up. This equals 2 hyperbolic tangent inverse of x over 1 minus x squared.